students. Welcome back to another hard topic. Rocks is where we left off last time, and we have spoken so far about the three main rock groups. And yes, Rolling Stones is not one of them, but no, we talked about the igneous rocks, the sedimentary rocks, and the metamorphic rocks. Well, in today's video, we are going to be exploring each of those rock groups in just a little bit more detail. So if you recall, last time we left off with igneous rocks, so we're going to continue there, again, giving a little bit more detailed information about each of the rock groups. So let's begin today with igneous rocks and how they are classified. Igneous rocks are classified according to two characteristics: their composition and texture. Composition is a word that means what something is made out of. So composition is basically referring to what's in it. What's in it? What is it composed of? Texture describes how something feels. So let's talk a little bit about composition first. Composition, the way in which you know what substances, what minerals, what elements, what compounds are found in an igneous rock is by looking at its color. The color of a rock can help you identify what it's made out of. Now, you may recall last week when we were talking about minerals and how color is the least reliable form of identifying minerals, but it doesn't mean it was the least important. Color with minerals and rocks are good indicators of what elements and compounds make up a particular substance. So in the case of igneous rocks, the composition is based on color. When you look at a color, if it's more red, it has certain elements in it. If it's more green, it has certain elements. And the colors in between. Color is indicative of what a rock is made of. So in general terms, we're not going to get into a lot of specifics here, but in general terms, an igneous rock that is mostly lighter in color, mostly light, is going to indicate that it is rich in the mineral quartz. And we're familiar with quartz from last week. So if an igneous rock is mostly light, it's because it is rich in the mineral quartz. And again, we're speaking in generalities here, but if an igneous rock is mostly dark, it's because it is rich in augite, another mineral. So if I were to show you a couple of igneous rocks here, and I'm just going to grab a couple out of our kit here. So here's a couple of igneous rocks. Hopefully you can see one is lighter in color, one is darker in color. You should be able to guess based on this information that one of them has more quartz in it, one of them has more augite in it. And in fact, that is the case. So we're not going to be getting into real specifics here as far as exactly what minerals are contained in each rock, just in generalities. Mostly light quartz, mostly dark augite. Now, as far as the texture of igneous rocks are concerned, the texture is determined by the size of the crystals. Some crystals form very slowly, some crystals form very quickly. And there's a couple of terms here that we're going to expand on in just a moment, but let me show you on this diagram. Lava. You may recall, lava is what molten material is called on the surface of the earth, on the outside, whereas magma is on the inside. We have a fancy name here, plutonic rocks. Plutonic rocks are those that are formed inside, and extrusive rocks that are formed on the outside. Now, let's go on to the next slide here and get to the difference between extrusive and intrusive. Extrusive rocks, if you think of the word extrusive, E-X-T, think about it for a moment. You could think of other words like exit, exterior, exoskeleton. When we look at words and we break them apart, we dissect them, the prefix X refers to the outside of something. In this case, it's talking about where an igneous rock forms, and more specifically, it's on the exterior or on the outside of the crust of the earth. There's another name for extrusive rocks, and they are volcanic. And that is simply because volcanoes are on the exterior of the earth. And when a volcano erupts and spews out the lava, it's on the exterior of the earth. So extrusive, volcanic, those words are synonymous in geology. And if you think about the change in temperature from molten rocky material to the atmosphere, there's going to be a very quick cooling of that molten material, and that quick cooling results in very small crystals. Here I have a sample of obsidian, which is otherwise known as volcanic glass. Obsidian is the middle picture here. Obsidian is an extrusive volcanic rock, and when it comes out of a volcano, it cools very quickly. And so the crystals are tiny, very tiny, so tiny that the surface of obsidian is super smooth like glass. In fact, obsidian, just a quick little tidbit of info here regarding obsidian. Obsidian is prized for its ability to break into really sharp layers. Some of the best scalpels still are those made out of obsidian glass, volcanic glass, a rock. These rocks have been used for thousands of years in human history. When broken apart, they form very sharp edges because they're itty bitty tiny crystals, and they can be used very effectively as knives. Very, very effective, and well, quite dangerous too. So some examples of extrusive igneous rocks include basalt, obsidian, and pumice as well. All of these are examples of extrusive. They cool very quickly. That brings us to intrusive. Intrusive, if you think of the prefix here, in, like inside of something, in the interior of something, intrusive refers to the inside of the Earth's crust. Now, if you've learned anything about Greek and Roman mythology, you might know the character, the Roman god called Pluto. Pluto is the Roman god of the underworld. And so geologists have used this word to refer to intrusive igneous rocks, as being called plutonic, named for the Roman god Pluto of the underworld. Now, because they form under the ground, it's like being in an oven. If you bake a cake, you might leave the cake in the oven to cool after you turn it off, and the baking still takes place in an oven that has been shut off. As a magma chamber is no longer active, it's still going to be hot for a while as it cools down. But as that cooling takes place slowly, the crystals that form can form much larger. Think about last week when I showed you that picture of the calcite crystals in that cave in Mexico, how huge they are because they've had a long time to grow. Well, with igneous rocks, the longer it takes to cool down, the larger the crystals can grow. Some examples of intrusive or plutonic igneous rocks include granite and pegmatite. Let me see. Oh, here I have a sample of granite here, if I can get it out of the box. Here is some granite. And if you look at it, the crystals, you can see the crystals, and you can see the crystals because they are so large. That's one of the reasons why a lot of people use different types of granite as countertops in kitchens, because the crystal size makes them look pretty. They look beautiful. But granite, pegmatite, both examples of intrusive plutonic rocks, and their crystal size are very visible. In fact, here's some pictures of them right here. So here's granite and here's pegmatite, both pretty rocks. And based on the color in the granite determines or is determined by the chemicals that make it up, the specific minerals that make it up, the elements that make it up. So different colors, different minerals from different elements. All right, so there we have the igneous rocks. Now let's transition to sedimentary rocks. We'll explore sedimentary rocks in a bit more detail now, starting with three different categories of sedimentary rocks. If you think back just a moment ago, the igneous rocks, we had intrusive and extrusive igneous rocks. Well, here for sedimentary rocks, we have three categories of them, and those categories are based on the origin of material. And when we say origin of material, we're talking about, well, where the basic raw materials come from. Where did the sediments come from? That's how we determine these three categories of sedimentary rocks. So let's begin with the first group. The first category of sedimentary rocks are those called the clastic sedimentary rocks. Clastic sedimentary rocks are those made of fragments. Fragments are another name for big particles that make something up, pieces of something left over. And some examples of clastic sedimentary rocks include conglomerate, sandstone, and shale. Here I have a specimen of conglomerate. This is the sedimentary clastic rock known as conglomerate. Looks like the picture on the left there. And if you notice, you have all of these different fragments, these different pieces that are basically glued together. It's those fragments glued together that form this particular category of rock called clastic. So clastic, first group. Next group are called the organic sedimentary rocks. And organic sedimentary rocks are formed from dead plants and animals. Probably the biggest example of this used by humans for a long time now is this rock right here. The Industrial Revolution was operated on this organic sedimentary rock, which burns. You may have guessed it, it is coal. But that's not the only example. Limestone. We live in an area here just covered with limestone. Take a trip down our river, the Delaware River, and you'll see outcroppings of limestone all over the place. But limestone, chalk, and coal are all organic sedimentary rocks because in each of these cases, the material that makes them up is from once living things. Coal, for instance, made out of decomposed plant and animal material. Limestone, chalk, made out of the skeletal remains of ancient aquatic marine organisms. In all three of these cases and other cases too, organic sedimentary rocks made from dead stuff, folks. Yeah, exciting. But very useful. These are one of the more useful sedimentary rocks that we can find here on planet Earth. That brings us to the third category of sedimentary rocks, those that are considered chemical. Now, these are kind of interesting. Chemical rocks, chemical sedimentary rocks are formed from inorganic processes like evaporation. Inorganic, as contrasted with organic from living things, inorganic from non living things. So, inorganic processes like evaporation. If you could do here's a bonus point opportunity for you folks. Take a little cup or a glass at home and fill it with just a little bit of water and put some salt in it. Stir it so that the salt dissolves, and then put it on a windowsill or a heater if you can do it safely. Put it in the sunshine and let the water evaporate. That evaporation process will leave behind a rock called halite. And that rock was made from the evaporation of the water, leaving nothing behind but the minerals left in it. You could actually color them, put some food coloring in that water too. You could make some cool chemical sedimentary rocks right at home in less than a week. Try it, take some pictures of it, send them to me, and I'll give you some bonus points. So here's some examples. Oh, check it out. Rock salt, gypsum, and calcite. All of these are examples of an inorganic process like evaporation that allows an increased slow concentration of minerals, accumulated minerals through evaporation or some other inorganic process that give rise to a rock combination of minerals. All right, so those are the three categories of sedimentary rocks, and that brings us to our final group, I should say, metamorphic rocks. And we're going to spend a little bit of time talking about two groups of metamorphic rocks. But first, just check out these samples, these pictures here. Some metamorphic rocks are just absolutely beautiful. One of my favorites is Tiger's Eye. I have that in my rock and mineral collection over on the side of the lab. You can check it out. And the way you hold it in the light, it's iridescent. It's like really pretty. Of course, the nicest metamorphic rock is number 2 on this one, gneiss. That's how you pronounce it. This is gneiss. And we have a lot of gneiss around here too, by the way. If you ever go hiking up by Jenny Jump Mountain by the land of make-believe, there's a lot of nice rocks up there, and you can tell them by the banding, the black and white banding like a zebra. But all right, let's get into there's also marble around here too, by the way. Marble Hill Mountain in Harmony, New Jersey. It's called Marble Hill Mountain for a reason. There's a marble quarry in Harmony there on Marble Hill Mountain. But let's get to our two groups of metamorphic rocks, which are based on their grain texture. So we're going to be looking at a variety of grain textures based on the formation of the metamorphic rocks, from very fine to fine grained textures. Let's just get right to it. And by the way, this chart is actually pretty good. I know you can't necessarily see it. Keep in mind that metamorphic rocks are rocks that have changed their form. And so metamorphic rocks are the result of changes taking place in other kinds of rock. So in this column here, you can see the parent rock, the kinds of rocks that result in a different type of rock. Like slate results from shale based on various changes that take place. Gneiss results from schist because of changes. Marble results from limestone and dolomite, actually. Quartzite forms from quartz. And we could go down this. Anthracite forms from bituminous coal. And these are just some examples of how metamorphic rocks are formed from other rocks. So let's get to it. Number one, the first group of metamorphic rocks are those called foliated. Now, foliated, this is a cool Latin word which means leaf. One of my favorite seasons of the year is fall, and my birthday is in the month of October during the fall, during the height of what's called the fall foliage season. The fall foliage season has to do with the different colored leaves on the trees. The foliage of a tree refers to its leaves. So it's no surprise that the word foliated, when referring to rocks, comes from the same Latin root, which means leaf. And so foliated metamorphic rocks, there must be some connection to leaves. And it's because of this. If you examine the structure of a foliated metamorphic rock, you will notice that they are made up of thin and flat layers, kind of like leaves. If you've ever noticed leaves in the fall after they fall on the ground, especially under a big tree with lots of leaves, those leaves pack on top of one another. Maybe some of you have a compost pile at home and you take all of your leaves and you pile them onto a pile. Guaranteed at the bottom of that pile the next year, you're going to see those leaves really compacted down on one another. Let me show you some examples. This rock here is a foliated metamorphic rock. I don't know how clear it shows up on the video. If I hold it a certain way, you might be able to see that this is made up of layers, very thin layers, like flattened leaves. This is slate, like the second example there. That is slate. Here's another one. This is schist, by the way. Schist, very layered. All of those little layers, that are layers of squished minerals, slate. Here's a nice one. Look at the layers in this one. This is nice. This is nice. The bands, if we hold it this way, kind of looks like stripes on a zebra. Those nice stripes. All of those are examples of foliated metamorphic rocks. And these rocks in particular tend to break along bands. Slate is a great example. If you have an older home, you might have a slate roof. Do I have some other bigger slate? I'll show you some other bigger slate in the lab. But there are different kinds of slate, different colored slate based on the chemical components. But slate used for slate shingles on roofs. It's also used for blackboards. It's also used for pool tables because they break in such beautiful flat layers. You want a nice flat table for a pool table. You want a slate table for that. So they break along bands, and it's because of this foliation that exists that enable them to do that. So once again, we'll finish up with 3 examples of foliated metamorphic rocks: schist, slate, and gneiss. And I think they're all nice in their own different and unique ways. But these are foliated metamorphic rocks. All right, let's get to the second group here, which are called unfoliated. So if foliated rocks are made of a lot of flat layers, you can probably guess that by putting the prefix UN in front of it means not. These are not rocks that have layers in them. Marble. Here's marble. Marble does not have layers. In fact, that's one reason why people like marble, because they are not banded, they are not layered, and as a result, they do not break along bands, which make them really strong. It's why artists, sculptors in particular, many of the famous sculptors in history use marble to carve beautiful carvings out of stone carvings because it's so strong. I mean, imagine making a sculpture out of slate. It's not going to last very long. It's going to break apart very easily, but not marble. Marble is very strong because it does not break along bands. So a couple of examples here of metamorphic rocks that are unfoliated include marble and quartzite. Now, that was a mouthful today. There was a lot of information unpacking those three groups of rocks. And so for this video, I'm going to call it quits. And the next video, I may show out of sequence. That's okay. But this video is done for now. And so I'm going to say bye-bye.